always forget to hit record for whatever reason. All right. So today we're obviously um, here. It's like, wait, we're at the ninth. Yeah, we're at the 12th. So today we're going to be covering just two topics. They're both not too long. The first is about ecosystem services and how we can evaluate in ecosystem and its services and what value it has to us. And then we're going to dive into a topic that I don't really talk about all that much, and it's more of I think of like an idealized version of the topic as opposed to a more uh, I think a more practical version is probably the correct way of saying it of the topic and thinking about ethics and economics and policy. Just as a reminder, Wednesday you'll have time to work on your lab, which we'll discuss before we jump into the topic for the day. And then we'll talk about two topics that relate directly to your lab, which is actually population biology and urbanization. So you have the chance to do your lab Wednesday if you so choose. You obviously don't have to. You can do it whenever you please. The lab is due the 22nd. So if you want to take Wednesday to do it, great. If you want to take Wednesday to watch TV, that's fine with, with me as well. It's no big deal. You choose how you use your time. But I'm giving you Wednesday, i.e., 2 days from now, to work on the lab. So let's let's meander over to Blackboard for just a second here. So just as a reminder where things are. So if you're on like the main page, right, you come in and it looks probably something like this. You go over to assignments, you go over to labs, and then your cemetery lab, which I'm doing here, first off is going to be here. Now, um, so there's a thing. So there's an example Excel file here. We're going to go through this in a second, and then there is questions. This is what you're going to be turning in, and then there's a handout that basically tells you how to do things. Now, before we do that, as I mentioned, and I haven't looked at this sign up sheet, so maybe you guys have all signed up for groups, and I'm just looking at things. So I see not everyone has signed up for groups. So there is a group sign up sheet if you would like to work with group members. So I see these three folks and these three folks and these three folks have signed up for a group. They've jot their emails down. So when you're working on any assignment here, besides your exams, obviously, you are free to work as a group. So feel free to sign up and work as a group. It'll take this assignment that will take, maybe 2 hours by yourself, and I'll chop it down to be maybe 45 minutes, maybe less, depending on how efficiently you work as a group. So, like I said, definitely, I always recommend signing up to work as a group. It makes your life so much easier, especially in this class. I know group work's not the best thing in the world, but I think generally speaking, I never really encountered any problems with group work in this class. So I feel like it's the way to go. So, but yeah, definitely, like I said, if you have time, definitely sign up for it. Now, as I mentioned, we're doing the cemetery demography lab first. I like this lab. Um, I like it better when we're in person because if you've read through this handout, the handout would tell you to go to a cemetery. The following week and talk about the data and analyze the data together. Um, but we're clearly not in person. So the way you have two options for how to do this lab. Now, the first one is if you live near a cemetery, which most people do. Like I live in Easton, Massachusetts, for example. It's not a huge town, but there are two cemeteries in my town alone. So if you want to get up and get out, go to a cemetery, look like a weirdo with a notebook in the cemetery, writing down birth and death dates, you can feel free to do that. You won't look like a weirdo. You'll just look like a person that's drawing on a notebook at a cemetery, and people can interpret that however they please. Though I will say no one has ever thought we were weird at the Arlington Cemetery when we were there as a group. Now, if you do not want to go to cemetery because you're lazy, you don't feel comfortable, maybe there's religious reasons for not wanting to go to a cemetery. I know those exist. Your other option is actually this link here, Interment. Yeah, Interment. Now, if you click Interment, you'll see this is a cemetery records online. It's a pretty cool little database. You don't need to sign in or anything like that. All you need to do is actually just scroll down on their main page and you get really cool things. So you get browse cemetery by regions, so you can see UK, Australia, United States, New Zealand, other countries. Special locations, so like veterans, flooded cemeteries, airship disasters, ship disasters. So they got lots of cool stuff. And then if you keep scrolling down, they have like very large and well-known cemeteries. For instance. um, not so much the hypothesis, but the specific idea of populations on Friday. But I thought I'd get you started thinking about collecting data. But you're going to try to develop a hypothesis of, is there a difference in life expectancy between Group A and Group B? Now, Group A and Group B can be whatever you want it to be. Now, maybe you're like me and you would just go right to the United States, and maybe you're interested in, is there a life expectancy difference between, uh, I grew up in Texas and I live in Massachusetts. Is there a life expectancy between Texas and Massachusetts, the North versus the South? Or maybe you want to be more North versus South because Texas is pretty diverse in its population. Maybe you want to do Alabama or Mississippi versus Massachusetts or California or East Coast, West Coast, or potentially, there's cemeteries here that are strictly for veterans. Is there a difference between veterans and non-veterans? Probably. I obviously wouldn't do any of these special collections that are train wrecks, because obviously the answer is yeah, people probably died before they were supposed to. But maybe you're interested in the UK versus the United States, Middle East versus Europe, whatever. You just need to pick two broad categories, just two broad categories, and say, is there a difference between X and Y? And try to think of a rationale why. Now, as I said, if I were to do this myself, I would choose the North versus the South. So I would choose, like I said, Massachusetts and Texas. So I would come over, I would click on Massachusetts, and I open it up in a new tab. And you'll notice you come down here and you browse cemeteries by county. And so Massachusetts has all these counties. And you say, okay, well, what do I do with this? Well, let's say, okay, I'm gonna look at first here at Bristol County. That's where I live right now. And say, okay, these are all the cemeteries that are in record in Bristol County. So I'll click on the first one and see what we get. It gives me some information about the cemetery, its GPS coordinations, blah, blah, blah. Now, as you scroll down, there may or may not be records. So for instance, there are records here. So for instance, this person, Marion Clapp Dixon, she was born 1910, died 1996. Perfect. So that's a piece of information that I need. Actually, one other comparison you can make is men versus women, or sometimes 1700s versus 1800s, those sorts of time ones. Doesn't have to be like locations. It could also be like races. You can also potentially do religions. That you can suss out any sort of categories from these records, which I think is actually pretty cool. You can also do like married versus non-married. That one's always a fun comparison, just as a note. Now, this is the information we need. This person was born and died in these days. So what I would do for this, I would hop on over to an Excel spreadsheet. Now, I would recommend you do this, like a Google sheet, like I'm doing here, and pop open year born, year died, and then what category it fits in. So I'm going to pretend that I'm going to do category. Sorry, I can't spell. I'm going to pretend I'm going to do male versus women, and I'll just show you what that looks like. So for instance, this woman, she was born in 1910 and she died in 1996. So that's exciting. And I know this. And so then we want to just calculate the age. I'm sure you guys probably know how to use Excel, but math in Excel is pretty easy. You would want to do the year they died, subtracted from the year they were born, and then Google likes to select autofill. And so we want to get their age when they died, and that's great. And so we have the year born, the year they died, what category. So I have male versus female. It could be North versus South, right? It could be Europe versus United States, Japan versus United States, whatever. It could be whatever two categories you want, whatever two categories interest you. It really depends on what you're interested in. So once you get this data, now the data, how much data you collect is dependent on how many people are in your group. Now, if you're going to work by yourself, um, you could feel free to get 100 data points. If you're going to work in a group of 2, I would recommend that you get at least 200 data points. And if you're going to work in a group of 4, I recommend that you get 400 data points. So that's kind of the way it breaks down. You're going to work by yourself, 100. Basically, no matter what you do, you're going to have to collect 100 data points. So it sort of scales, right? If you have 3 people in your group, you should get 300 data points, right? And what does a data point mean? Well, it's just people, right? How old was this person when they died? And whatever metadata or male versus female, north versus south that you're going to get. Now, once you get all this data, you're actually going to, and it actually shows you kind of how to do it here. So I sort of put this Excel sheet, and as I mentioned, it is available for you right here in Blackboard, so you don't need to worry about jotting this stuff down or anything like that. It's there for you. But you'll notice what I've done here is I created an age class. Now, what I've done is you go and basically you bin your years in 5-year age gaps, age groups. So in this case, I have age class 0, which is people that were born basically 1 year or less. So if someone was born, say, like in 1955 and died later that year in 1955, you would just say they were 0 years old because that's sad, and we won't think obviously any more about that. Then the next age class would be 1 to 5, 6 to 10, 11 to 15, and so on and so forth. Now, you might not have, when you collect your data, you might not have individuals that fall into these categories. That's okay. Just do 5-year age gaps. So for instance, pretend I didn't have anything from 16 to 20. Maybe I just do 21 to 25. Right? So you don't need to worry about skipping. But again, always do 5-year age bins. Now you're creating what's the highest age. So the highest age for this class is 0. The highest age for this class is 5, and so on and so forth. Oh, this one will be 25 now, but you get the gist. And what you want to do is look through your data. Now there's a number of ways you can do this, but basically you want to figure out in each age class how many people have died. Now in this case, my age class of 0, I had no deaths. But in my next age class, I had 5 deaths. The next age class, I had 10 deaths, 15 deaths, and eventually 20 deaths. This is pretty extreme, right? I mean, it's to 25 years old, right? But it's not exactly what it would look like, but you get the idea. How many people died in each group? Now, from there, you want to know how many survivors you have. Now, in this hypothetical example I've given you, I only have 50 data points. Now, you have to have more data points, obviously, but you basically want to take the total number of people you sampled. So in this case, I sampled 50, and I want to subtract the number of deaths from it. And then from there, for below it, I always want to say, okay, given how many people survived from the previous age class, how many people did I lose? So 50, and then I minus 5 from here, so I have 45 in this age class. And you guys probably know Excel allows you to drag down and do all that fun stuff. So how many survivors per age class do I have? And then from there, I want to calculate the proportion surviving. Now, it's pretty straightforward. The proportion surviving simply is the total number. Now, in this case, it's 50. I'm sorry, the number of survivors divided by the total number of people, which gives me, in this case, a proportion surviving of 1 or 100%. And with Excel math, I just drag it down and it does the math for me. And then I want to calculate the final thing, which is simply the survivorship per 1,000. And to do that, all I simply do is take 1,000, multiply it by my proportion surviving, giving me how many people per 1,000 survived. Now, why do we do survivorship per 1,000? I'm sure you guys have probably seen like, oh, we look at, infection rates per 1,000. And it's just a really common way to sort of standardize data sets across them. There's other demographic reasons that we won't go into, but we will standardize ours to 1,000. Now, you might ask yourself, okay, I did all that stuff. What do I need to create from there? Well, we're actually going to be creating what's called a survivorship curve, and we'll talk more about these on Friday. But again, what you end up doing is you taking these age classes right here. So in this case, 0, 5, 10, 15, 20, and the number of survivors from each of those classes. And you basically just make a scatter plot where you have the number of survivors per 1,000 in the age class here on the bottom, and you get this nice little curve here. Now, what you want for your data is a curve for each of your comparisons. So in this case, I just have one curve, again, because it's just an example. But again, we have one curve. I could pretend this is my curve for males, and then I'd create another one for females, or north versus south, east versus west, whatever you'd like to do, whatever your question Yes. And so I want to just go over that. We'll talk more about populations next, when we come together next time. But I wanted to, give you, like I said, you guys have Wednesday to do the cemetery demography lab. Just me giving you time. So, but I did want to introduce the idea to you: what's going to be going on, how do you collect your data, so on and so forth, and basically basically you're going to get this curve, and we'll talk about how to interpret it next class. Now, do you have to have your data and everything done by Friday? No, absolutely not. I would be surprised if any of you did it Wednesday. Just, just from what I remember being as a college student, I wouldn't do it Wednesday myself. But I'm giving you the time Wednesday. I do recommend you take that time on Wednesday to do it. And again, we'll talk more Friday about it, because Friday we're going to be talking about cities. We're going to be talking about population biology. So we're going to really get into it, how to interpret the curve that you're actually physically making. All right, so that is it. This is recorded, so if you forget something, we only went 15 minutes over this, so you'll have plenty of time to go back and take a peek at it. Does anybody have any questions that you sort of saw that confuse you, or maybe you read through the document and something you didn't quite understand?
So, Professor, are you going to be putting in the assignments on Blackboard today after class? Because I don't see it on Blackboard.
Oh, is it not? Oh, okay, it should be on there. It's on mine. Maybe give me a second. Let me see something.
Oh, never mind. I just saw it now. It's
I
under the
see.
folder now. Yeah, okay, got it.
Yeah, it's set. Okay, yeah, so it should be there. Yeah, I'm saying I thought I said. I mean, it's there in mine, but maybe it's not on student.
Oh no, actually, like I see like the PDF, the one that says like the cemetery demography lab sample table, but I don't see the actual assignment.
It's the Excel is up, but like
Yeah.
the document is not there. That's what
Yeah,
it is.
like the
No,
Excel document is there, but like the actual assignment isn't there.
Yep, I can fix it. Give me a sec. It's not there because you guys signed up for groups, and it's set as I fix it. I have the power. I have the power to fix it. Be kind of a stupid if I didn't have to fix that one. All right, it's set as an individual assignment right now, but eventually it'll set to a group assignment. So if you do decide to work as a group, you'll be able to submit as one document per group. That just makes it easier. Let me do the same thing for the biodiversity here. Yeah, this is what Blackboard looked like behind the scenes. It's not very exciting. So I don't know if you guys have ever seen it. Not very exciting stuff. So, but yeah, it should be there for you guys now. And again, I recommend working as a group. If you're not going to work as a group, just let me know in the spreadsheet as well. Again, just because like I recommend it. So even if you don't know someone, like say I don't know if these people know one another, but even if you didn't know each other, it's still a good thing to get to know other people at Bentley. You guys are all probably at a similar point in your careers, generally speaking, out of schools when you take classes like this. So generally, a good thing to get to know your classmates. It's always a good thing. Just as a note, friends are good. All right. Does anybody have questions about our lab? You should be able to see everything now because I fixed it. Does anybody have any questions?
There's one more thing is I'm opening the document up right now, but you put the website for like where we could collect the data points, or could you mention it one more time?
Oh yeah, so it's if you go into the handout, the document, it's actually one of the only things linked in the document.
Okay, I
So
see it. Yeah, I got it.
In highlighter. There we go.
Okay, got it.
Yep. Increment. I don't know what that means. But yeah, like I said, if you want to go outside, it's kind of rain. I don't know if you guys live in Massachusetts or not, but it's raining in Massachusetts today, so it's not the funnest thing. But the online one is pretty straightforward, and probably is the most efficient of the two things, and it allows you to ask better questions. It's hard to infer, like where they were born from a tombstone. All right. So today we're going to talk about a topic that I think you guys will find interesting. Um, well, two topics. Um, I think it's a pretty interesting uh, take about nature, and I think it will help dispel a lot of um, I think a lot of issues people have with environmentalism. And so let's dive in. If you have any questions, feel free to interrupt me or dump a message in the chat. And so we'll talk about this first part. If you guys want to break, we can take a quick break, and then we'll have um, a chat about ethics and stuff like that after that. So um, start off with this cartoon, and I think it really captures our sort of view of many things. As I mentioned, I think the first class I watch Hulu. And as I watch Hulu, I see ads all the time for turning your side hustle into your primary job, or making money off your side hustle, or something like that, or turning your passion into money, right? And I think this cartoon captures that idea, but it captures it in the more of the respect that we're thinking about for this class. And the guy with the sweet mustache says, as you go through life, take time to monetize the roses. And that's obviously in direct contrast to take time to smell the roses, which is more so appreciate life, versus this guy saying make sure you squeeze as much money out of life as you physically can. And if that's not reflective of society, um, there's probably lots of things else that are also reflective of society, but I think this does a pretty good job about that. So let's dive into how this gentleman potentially might monetize the roses. Now, what is an ecosystem? Now, I don't know if you guys have heard ecosystem as a term before, but it's pretty broad. Um, an ecosystem really encompasses a lot of different things about a natural environment, but you can also think of like it's sort of a broadening not just natural things, but also the urban environment, right, or the suburban environment, right, human-based environments. And it's really kind of a combination of natural and unnatural things as well. Now, when we think about what an ecosystem is from a scientific definition, it's just how the living and the non-living come together, interact, and shape the environment together. And that's what we call an ecosystem. Now, when we say living, the scientific term for this is biotic. And when we say non-living, we think things that are called abiotic. So biotic versus abiotic. Just just scientific terms. If you, for instance, if you buy the textbook that I said you don't have to buy, they'll talk about biotic and abiotic. So I figured I'd just mention it. Now, when we think living, it's everything you can see that's alive. Now, um, it's things that eat plants, it's things that eat dead things, so herbivores or tridivores, things that eat other things, carnivores, primary producers such as plants and algae, and omnivores such as humans that eat kind of a little bit of everything. Um, and so that's what the living parts are. Every living thing in the ecosystem is the biotic component. Now, the abiotic component is a much longer list. This is just a small number of things um, in an abiotic component, but includes things you think about on an average everyday basis, like sunlight, temperature, water, wind, and nutrients. So, food items for things that don't eat other things. But it also includes a wide variety of things like geography and terrain and climate and all these other factors as well. So the biotic component is probably the cooler part of this list, but the abiotic component is certainly important. Now, I don't want you to get sort of tripped up in thinking that they're separate entities. Biotic shapes abiotic and abiotic shapes biotic. So they are directly intertwined with one another 100% of the time. You might think, oh, how does sunlight affected by herbivores? But for any of you that have gone walking in the woods, you know that when you walk through the woods, there's very little sunlight that makes it down to a sort of average everyday temperate forest here in New England. Thus, herbivores are shaping sunlight. So everything essentially interacts with one another. Now, ecosystems, as nature is just generally, are dynamic, and they vary through space and time. Now, what does that mean? Well, take a walk through the woods, right? If you walk through the woods from say you're in the Blue Hills in Massachusetts, and you walk from the bottom of a hill to the top of the hill, you'll notice that ecosystem, which is just one ecosystem, changes from the top to the bottom. Or if I walked from my backyard into my neighbor's backyard, again, the ecosystem changes in that short period of time. Now, it also changes through space. As you guys probably know, a walk through the woods in the summer is very different than a walk through the woods in the winter. So that is a sort of important part, just kind of like a foundational thing. Ecosystems There's lots of them out there. I'm sure you guys probably heard things like temperate forests or taiga or tundra or desert or rainforests. Those are all different types of ecosystems. And again, they're all an interaction of living and non-living entities. Now, biology is really cool, but biology is not separate from chemistry, nor is it separate from physics. Just to let you guys know. So that's kind of the interaction between all the different scientific things that act to shape an ecosystem. But all of these things and how well they are maintained, i.e., how strong they are, or essentially what their integrity is, comes together to be what we call ecosystem integrity, i.e., how healthy is an ecosystem from day to day. And I know you guys probably don't think of like health of an ecosystem as like like an important thing or anything like that, but ecosystems have health, and you can assess health in a number of different ways. We won't refers to basically how many different species I have living in a single area. And so when something is very, very biodiverse, it has a lot of species. When something is very, very low biodiversity, it has a low number of species. So that's sort of what that means. Now, it's a really interesting link here. Now, when there are more diverse ecosystems, i.e. higher biodiversity, it makes ecosystems function better. It's kind of a weird thing. Now, just to give you this really classical example, we have this one aquatic ecosystem. So you can think like a lake or a pond. The phytoplankton, i.e., like the photosynthesizing algae in the pond, with very, very low biodiversity, they have very, very poor nutrient removal efficiency. However, if you take the same number of phytoplankton or algae, whatever you want to call them, and put many, many different types of species, the nutrient removal efficiency is very high. So kind of a weird thing, but I think we could best sort of link it to maybe problem solving with humans. The more diversity of opinions you have, the more likely you are to solve a problem. I always kind of make that link in my brain. I know a lot of people don't, but that's why I've always seen it. More diversity of opinions make you better able to tackle a problem. And that's really true in nature as well. More biodiversity, better functioning, healthier, an ecosystem with higher overall integrity. Kind of a cool thing. I worked on this a little bit when I was a grad student, to little effect. It's very hard to do with microbes, but very, very effective with other things as well. But I wanted to make mention of this. If you want to read a little bit more about this Coastal Wiki is a fantastic resource that talks a little bit about this. But again, really kind of a cool thing. Biodiversity helps maintain ecosystem integrity with lots and lots of biodiversity. So now, this wouldn't be a course about that you guys would be interested in taking if humans didn't factor into this in some way, shape, or form. And human activities, whether they're isolated or in combination with one another, influence ecosystem processes. They influence the animals, they influence the geography, they influence the nutrients, whatever you can think of in an ecosystem, humans have influenced somehow. Now, it could be something as simple as directly taking from the environment, i.e. overfishing or deforestation, or something where we add species, such as species introductions. Those happen all the time. For those of you that live in New England, you might have heard of like gypsy moths or maybe the longhorn beetle from Asia. Those are examples of species introductions. Or we can think of things that happen on a much wider scale or maybe potentially longer time periods where we have changes in sedimentation, i.e. we alter rivers. You can think like dams, things like that, but also dredging. Or maybe much longer term things like climate, or essentially like intense or potentially long-term additions of nutrients or waste into the environment. So clearly these things do not happen independently. You can have nutrient pollution, climate change, species introductions, and deforestation all happening in the same ecosystem. But again, humans act to influence ecosystem processes, influence both the biotic and abiotic components themselves. And that's probably not overly surprising, right? I mean, when you look around us, when you look, the way humans live relative to the natural world, it's not surprising that humans influence ecosystems, right? So the topic for today, with the idea of what an ecosystem is, what ecosystem integrity is, and how biodiversity factors into that is, is there a dollar value for nature? And do we derive benefits from nature even if we don't think we are? Now, this gets us to a broad term by which we call ecosystem services. Now, these are it's a term that really it has a really interesting origin that it would take me like 10 minutes to explain, but it's really at the intersection of science and economics and policy. It's less so of a scientific term, but it was more a term applied to like get people thinking about policy and nature and economics and nature. But anything that is an ecosystem service, it's something that benefits humans directly or indirectly from just the natural way an ecosystem works. Now, this is so important that year after year after year, starting in 2005, the United Nations, in their Millennial Ecosystem Assessment, um, essentially designated ecosystem services into four key categories and attempted to essentially show that they're being not only degraded, but also how important they were to average everyday human life. Now, if you want to read up a little bit of this, here's the link here from the FAO. It's a pretty interesting link. If it's a long read, but if you do want to take a peek at it, I recommend it. But they defined four key services. Again, these services are ecosystem services, and they're provisioning services, regulating services, cultural services, and supporting services. So let's dive into these four things. We'll start with the most easiest to understand, and this is going to be our provisioning services. These are physical goods that we take from the natural world, and these are things that people directly think like I went into nature, I took this lobster, I took water, I took timber, I took plants, I took gas, medicine, oil, whatever. I took it from nature and I sold it. And that's the direct marketable value from nature. I sell something I took from nature, right? And that's sort of the easiest to understand, right? I took something, it has a direct value, right? I got a lobster. This lobster is $7 a pound. I sold it to some guy. I made money, right? That's the easy, and that's the sort of the most thing people think like this is how I get money from nature is I take something from nature and I sell it, right? I didn't have to pay nature anything to get it. I just took it. I had gear or whatever, or I had machines to get it, but I didn't have to pay nature for it. Nature gave it to me for free, and I commoditized it. So that's what most people think of as the only value you can take from nature. But the reality is there's four categories. And if that's the first one, there's clearly more services coming after that have a direct value. And these are the indirect ones. Now, the first one is actually going to be regulating services. And this one, we get so it's I don't want to um oops, sorry about that. I don't want to like overstate how important this is, but we get so much economic value from just this one service. And these include things that you might not think about, right? Pollination, decomposition of dead stuff. So when a tree dies, it doesn't just hang around, it goes away over time. Water and air purification, again, something we don't think about, but we need clean drinking water, we need clean air. Erosion and flood control, we need to control the way our rivers flow because as we as we saw in New York recently with these floods from the hurricane, right? The entire basically there was huge floods throughout the New York City subway, right? And that's something nature can help prevent. We can sequester carbon, and we can also regulate climate. And so these are things, again, regulating services, they help sustain ecosystem health, but we take a direct value from them, even though we don't realize how direct it is. Now, just to give you an example, I'm going to give you two examples of this. The first is pollination. Every year, the United States, just by itself, derives indirectly about $225 billion every year from pollination provided not by farmers that bring bees, but just from naturally occurring insects. $225 billion. More than our farm subsidies, $225 billion. That's a lot of money, right? I mean, billion is obviously no, that's a third of our military budget. So that's no small chunk of change. But could you imagine if we had to pay for that service, how much more expensive food would actually be? Again, a lot of money, nothing. Depending on who you ask, about a $500 billion tax on our medical system just from air pollution. And so those people that live in cities, they suffer from this more. Those people that live more in the suburbs suffer from it less. So it does The air purification that is provided for us in natural settings, i.e., like, I have tons of trees around me. So the air purification provided by trees here saved me quite a bit of money in medical bills over time. So two great examples of, well, the first one was much better than the second one because I couldn't give you a good dollar value for the second one. But again, lots of great stuff that are provided for us, but for free by our beloved Mother Nature. So that's our regulating services. Now we step up to cultural services, and again, this one might seem like a not a valuable thing, but as we'll see in a case, excuse me, as we'll see in a case coming up, um, things like recreation and recreational fishing, stuff like that can be quite valuable as well. But a cultural services is basically our connection with nature. Now, this includes recreation, art, music, architecture, spiritual sustenance, as well as science education. Now, this idea of our connection with nature, there's a fantastic quote from Teddy Roosevelt back in the day, but you know, that's back in the day. But the scientific way to think about this idea about our connection from nature is actually derived from E.O. Wilson, so the gentleman I showed you in our first class together, and his concept of biophilia. And his biophilia hypothesis is that humans have an intrinsic connection with nature, and so that intrinsic connection with nature, even though we don't think it's there, it still does exist to some shape or form. And so it does have a value to us, right? I'm sure you guys, many of you have probably been to a national park. You pay to go to a national park, right? Maybe some of you are artists or musicians. Maybe you go to the woods to draw, or maybe you go to the woods to play music or listen to music, or maybe you have a religion that's involved with being out in nature, or maybe you're like me and your entire career is based upon telling people about how awesome nature is, right? And so there's ways we can derive both indirectly, or in my case of myself, I derive my part of my salary directly from just talking about nature and stuff like that. So there is a cultural connection with nature. And now that brings us to the final one, and this is sort of the most abstract one, and this is the one that I think is probably the most difficult to understand, but it sort of is the underpinning of sort of everything else we've talked about. And then these are the supporting services. They include photosynthesis, the cycling of nutrients, making new soil, cycling of water, and forming habitats. All these things come together. Basically, they're the interactions between the living and the non-living stuff. It's basically just nature doing its thing. And the reality is the supporting services provide the cultural services, they provide the regulating services, and they provide the provisioning services, right? Photosynthesis gives us timber and plant fibers, right? Certain other things like soil formation helps us with things like water purification and helping potentially grow more food and other things. So again, kind of a weird thing to sort of wrap your head around, but again, they do provide the bedrock for all the other things that act to support humans. Sometimes I think like maybe they're not simple enough. I never know. Oops, go back. Oh, there we go. All right. So now, if something has a direct benefit to humans, there's a value to it, right? That's kind of how an economy works, right? If I can sell you a lobster and I can sell lobster and someone will buy it, lobster has value, right? And so if lobster has a value, if an ecosystem has a value and the services ecosystems have a value to humans, can we put a price tag on nature? And so if we think of a hypothetical situation here where we have people living and there's agriculture and aquaculture and recreation, is there a way to essentially assign a dollar value to not just those things, but also the other aspects of the ecosystem, such as, water filtration and so on and so forth, that we could put a price tag on, right? And if we could put a price tag on an ecosystem, can we use it as a mechanism by which to protect an ecosystem and the services that it provides? So let's talk about trying to put a dollar sign on an ecosystem. And I don't know if these numbers are surprising to people. I don't know. like when I tell people this, I always kind of get a mixed reaction. Like some people don't seem surprised at all. Other people are like, they look at me like you're lying. Other people kind of look at me like I don't really care. So it's kind of, I never really know what people's sort of reactions to these are. But we started in 1997. So a group of scientists led by Costanza, not George Costanza from Seinfeld, but a gentleman named Costanza. He and his group of scientists, there's a bunch of them. They estimated that the combined value of the world's ecosystems, i.e., their natural capital, was about $33 trillion. Now, in 2011, he and some other folks actually revised this estimate, and they basically actually quadrupled it, or just about quadrupled it, to be about 125 trillion bucks. Which I don't know about you guys, but something that's 5 times the GDP of the US seems pretty dang big to me. $125 trillion, just nature doing its thing. And this is just nature doing its thing in a way that benefits us. And this is not even nature doing its thing like because it's just being nature, right? Which is kind of a remarkable number. $125 trillion over a yearly period, which is, again, huge. So how did they come to this number? Well, they started to look at they started to break the world down into different ecosystems. And they said, okay, what ecosystem services do these ecosystems provide? And how can we assign a dollar value to them? Now, there's some math that goes into this, but certain ecosystems or services were more valuable than others. So for instance, like timber was less valuable than storm surge protection, right? Or medicine was more valuable than, say, harvesting lobster, right? So they sort of did some math, and I can provide the paper if anyone would like to read it. But they came up with some numbers. Now, the numbers varied pretty wildly. Now, the most valuable ecosystem services out there included things like seagrass beds, where they valued them at about $19,000 per hectare. Now, a hectare is about 2.5 acres, for people who don't know what a hectare is. Wetlands such as salt marshes, bogs, things like that were valued about $15,000 per hectare. Floodplains were valued at about $21,000 per hectare. So just parts of the land that were designed to divert floods away. Very, very valuable thing. Does anybody want to take a stab at how valuable cropland is per hectare? So like just growing corn or soybeans or... No one? Well, it's a lot less than the numbers I've put on the screen. Actually, a hectare of cropland, doesn't matter what crop you grow on it, is only valued at about $1,900 per hectare. So 10 times less than a seagrass bed. So just to put that in perspective. So really, really valuable number, right? Lots and lots of money. Trillions of dollars is clearly even millions of dollars is nothing. I guess for an average day person, millions of dollars is a lot of money. But when we're thinking about global capital, trillions of dollars is quite a lot of money, right? So, yeah, again, I always get astounded every time I think about this number, but maybe you guys don't. So, if ecosystems have a value, can we use this value to convince people to do 2 things? Deter future development, i.e. further degradation of ecosystems, or potentially restore damaged ecosystems to regain lost capital, right? When we look out at, say, the city of Boston, right? For those of you guys that know anything about the history of Boston, Boston used to be one giant coastal salt marsh, so coastal wetland ecosystem. That was Boston. It was a giant salt marsh. And we essentially changed that overall to basically fit our needs as a society, right? Filling in the marshes, allowing us to put cities and so on and so forth. So can we convince people to do less of what we did with Boston, or potentially taking Boston, and obviously we can't do this, but taking a place that's been degraded and going back to the way it used to be as best we physically can? And so we're going to talk about that next, but I just want to make mention of a couple things. Now, by putting a price tag on nature, some people do worry about that because, as we've talked about, if there's a way to monetize nature, people will commodify it. And people argue, including some folks here, including this paper from I forget his first name, but Macaulay in 2006, he argued that something should not be for sale. Thus, we should not put a dollar tag on nature, because he argued that there might be diminished returns, right? We might tragedy the commons out of something that has a dollar value. Conversely, our friend Costanza, not to be confused with George Costanza from Seinfeld again. Sorry, I watched Seinfeld yesterday, so George Costanza's on my mind. That valuation is not the same as a privatization, or commodification, i.e., just because something has value doesn't necessarily mean it's automatically going to be commodified, and that essentially evaluating something is the best way to protect it. So let's you can take a peek at this flowchart if you want to take a peek, but I actually want to dive into a case at what commodification of an ecosystem means. Now, we're going to talk about one of the most absolutely stunning ecosystems on the planet. And if you've never been to the Florida Everglades, I know Florida is a, is a weird state. I'm sure you guys probably know the Florida man meme. It runs from central to southeast Florida. It's called the River of Grass because there's massive amounts of what's called sawgrass and mangroves, cypress swamps, and prairies, where you just have this massive amount of water flowing through Florida down into the Gulf of Mexico. And as I said, it's the most beautiful ecosystem I've ever been. And I hope this probably doesn't do justice, but just Google what the Florida Everglades looks like. It is, like I said, it's absolutely beautiful. Now, it's a wetland. Clearly, it's wet. Right? That's what a wetland means. When someone says wetlands, it just means something that's wet for an extended period of time without drying out. But it does filter massive amounts of water, provides huge amounts of carbon sequestration, provides home to numerous wildlife, birds, alligators, endemic species, so species that are only found in the Florida Everglades, such as manatees. The Florida manatee, of course. There's other manatees, caimans, anything you can think of. There's beautiful wildlife, rich wildlife. There's rich recreation. There's rich cultural stuff there, and there's beautiful, awesome science that goes on there as well. And so, if I haven't made the case for how awesome the Florida Everglades are, I don't know what else I can say, because it really is absolutely an incredible ecosystem. Now, as I mentioned, it flows from about the middle of Florida down to the end of Florida. And for those of you that know about Florida geography, about the middle of Florida ish, that's where Tampa is. And then you kind of go down to like Orlando, and all those other places that I can't think of the name of, eventually till you reach the Miami metropolitan area, which has about 3 to 4 million people in it. And so this area of Florida, which used to look only like this, is pretty heavily colonized by people, right? Florida is what, the third most populous state in the union. So the Florida Everglades, because it's so heavily populated, again, flowing this way to this way, people developed on it, because Florida's I mean, it's humid as heck there, but it's a nice place to live year round. And Florida has some really rich agricultural lands for growing, things that grow in tropical climates, such as citrus. And so, because people wanted to live in Florida, the Army Corps of Engineers, among with many other people, started to drain the Florida Everglades. So this is the historic flow of the Everglades. This is provided from the U.S. Corps of Engineers. It used to flow, again, from about the middle of Florida all the way down there through draining, redirecting. Now, very, very little bit about it. I think it's about 5% of the water makes it down to Miami now, with the most of it being diverted out this way. So clearly, 70 years of change from this to this is pretty dang dramatic. And I think this map does all the justice that I need to say how dramatic it is, which is pretty cool. So, and the other thing I'd like to mention, it happened in a very fast period of time between the 1970s and 1980s, so about a 10-year period. So pretty dramatic in a very, very short period of time. I'll give the Army Corps of Engineers one thing: if they want to do something, they do it. It's absolutely incredible how fast our military works to eco-engineer things. Really, really is crazy what they do. So now, I don't think I tell you guys changing an ecosystem that much is bad. One thing I like about not that I have things that I dislike about your generation of Gen Z, of course. like I said, I have nothing against Gen Z or anything. I don't think I'm like a crotchety old man. But one thing I love about Gen Z is that you guys, of all the generations that have come through this planet, are by far the most environmentally conscious, which is good. My generation is, I think a close second. But your generation is by far more environmentally conscious. So I think a lot of stuff I tell you guys in this class, you're gonna be like, yeah, no crap, because obviously this is bad, right? Whereas I show this to my mom, she go, okay, they just made Florida better. Who cares, right? But you guys know when I show you this, it's bad. Now, pretty much immediately after they started doing this, people started to um, notice radical changes in Florida, not just from the development part, but just in the nature. They started that these pine rockland ecosystems started to disappear. Now, pine rocklands, they don't look like very much, but they are unique to Florida. They're not found anywhere else. And if something is unique, it has unique wildlife that live in it. So when you start to lose an ecosystem like this, you start to lose unique wildlife, and that's what we're seeing in Florida. And pine rockland ecosystems are now the most endangered ecosystem in the United States, which is saying something because we have a lot of really tarnished land out there. And the surrounding habitats, you can imagine directing this much fresh water in a different direction dramatically changes the coastal environments. And you'd be absolutely correct. The surrounding habitats, such as Indian River Lagoon, were negatively affected. And this led to destruction of massive amounts of seagrass beds and the manatees that depended on those seagrass beds. But it also dramatically affected the economy of Florida. So, for instance, the bone and the tarpon fishery no longer exists in Florida because of the way they changed the Florida Everglades. The loss of revenue, if I'm not mistaken, cost Florida about $500 million a year. I think that's how much the bonefish and tarpon fisheries used to be. But I think it was about $500 million. I forgot to check my numbers. So again, some negative effects on the environment, some negative effects on the economy, taxes, so on and so forth. So why am I telling you about the Florida Everglades? And why am I talking about it in the context of ecosystem evaluation? Well, as I mentioned, maybe if we can assign a value to an ecosystem, it's an easier thing for people to understand why destroying an ecosystem is bad, or potentially why bringing an ecosystem back to life is a good thing. Because if you're going to convince people to do something with taxpayer-funded money, I mean, some people can never be convinced because they hate spending of taxpayer money. But if you're going to convince people, you have to show them there's going to be a direct value, a direct benefit to them, right? That's just kind of the way things work. So this brings us to restoring the Florida Everglades. Now, restoration is reactionary. The best way to handle nature is to just leave it alone. But restoration is reactionary, trying to fix all the stupid things we did. So in 2000, Congress, in one of their last great environmental actions, you guys, for those of you that know, this 2000 was probably the start of the really heavy identity politics in the United States, and basically meant that like nothing really gets done. I mean, to put it mildly. And so this is, I think, probably one of the last great environmental things we've done. But we next. Just on our military. So find some balance, right? If we've destroyed these ecosystems, how can we restore them as best we can? Now, the question we could then ask is, if ecosystems are assigned a monetary value, would there be more of an effort to protect ecosystems, or would it be easier to convince people to restore ecosystems? So let's talk about what they did with Florida. So let's look at SERP's numbers. Let's look at their calculations they did. So they summarized some key ecosystem services, looking at 6 in particular, and these are the net estimate values over that 50-year period. So $11 billion investment. So, and again, this is just providing value mostly just to Florida, right? I mean, that's who's going to benefit from groundwater purification and so on and so forth. Well, I mean, obviously people come to Florida as well, but most of it's going to Florida, right? We have groundwater purification leading the way at $13 billion. Real estate at $16 billion. People like to live next to non-degraded pieces of land, right? People like the woods. People like the scenery of Florida. Park visitations at about $1 billion. Open space, just like open space for people to go and do stuff in, $800 million. Fishing, both commercial at $500 million, and recreational fishing at about $2 billion. And then wildlife habitat and hunting at about $12 billion. So when you do the math, it comes out to be about $46.5 billion. And when you calculate a return on investment, or that ROI, you get 4.04. So you divide 46 billion divided by 11 billion, which gives you about, for every dollar spent, the state of Florida, the federal government, whatever you want to say, derives $4 back. And that's pretty dang good. That's pretty dang good. A 4-to-1 in return on investment. That's fantastic, right? I don't know if you guys probably invest in stocks, but like when people were buying those GameStop stocks earlier this year, they were buying them for like a few dollars, and they were selling them for like what they got it to like $300 or $400. They were making like 100 times their ROI was like 100, but most people are generally happy with like a ROI of like 4 or even like 1, right? It's pretty good. Especially considering when you don't think about, if you just said, okay, real estate, park visitation, and hunting, right? If you said things I can directly derive from nature, you still get a lot of stuff you directly derive from nature, right? And that's not even including the groundwater purification, which is hugely important, right? We all know what happened in Flint, right? Flint, Michigan. Groundwater is so important. Water is so important as a resource. So I hope the Florida Everglades really shows you how you can apply the valuation of ecosystems. Now that, as I mentioned, that's hard to do and might potentially be dangerous, but how you could potentially use the valuation of ecosystems to not only convince people to restore ecosystems, but also to protect them. Now, Massachusetts does a pretty good job of protecting our ecosystems and restoring them. So for instance, there's the Harbor Island Restoration Project that's going on right now. So for those of you that don't know, off the coast of Boston, essentially like the cup that is Boston Harbor, there's a bunch of islands. We beat the crap out of them for the past 100 years, but we've actually taken a plan up in Massachusetts to restore them. It's about a $5 billion plan. The ROI on that seeks to be about 5 to 6 times the investment. But again, just fixing nature helps protect investments, helps protect the economy, and so on and so forth. And so I hope I've convinced you at this point that ecosystems are valuable. They really are. And I think the Florida Everglades is a great way to show that. I hope that $120 trillion thing is a great way to show that as well. But they are vital to us. We're not separate from nature. We just aren't, right? If we've learned anything from lessons of like, what happened in Flint, or what's happened in New York City this past week, or any number of large hurricanes or floods or whatever, is that nature can help prevent those things, but it has to be there to help prevent them. And so while it might not be so fun for a developer to have to think about a wetland, that wetland provides a crap ton of value to that developer, even though they don't think it's going to. And so ecosystem valuation is tough, but it does show you nature does have some overall value and does have a worth to it. It really does. So this does factor into sustainability, because again, sustainability as a concept is preserving things for the long term. Now, what does the sustainability for the environment means? Well, it means preserving the environment, restoring the environment so it's there for a long term, keeping these ecosystem services for the long term. Because again, even though we don't think about it, direct value from all of our ecosystems worldwide. It's kind of a cool thing. All right, so that's part one. That's ecosystem evaluation. I think it's a pretty cool one. One of my favorite topics to think about, because it really does show you like how full of crap people are when they say, "Oh, I can't factor in this species of bird because it hurts my bottom line." Well, that's just dumb. It really is. So would you guys like a break? You want to keep going? I don't have an opinion. Well, I have one person, so I'm gonna assume that's everyone. All right. All right. So this one, interested to hear your feedback on this. Because I said, I think I mentioned in the beginning, this is more of an actualized reality of it, as opposed to I'm sorry, a wanting reality of this. That's probably the best way to think of it. It's probably like I wish this is the way we wish things were. But the question we can ask, and that's what we're going to try to sort of jump around, um, and we're going to jump around it through the lens of ethics, economics, as well as policy, is how do we make decisions that protect the environment? Um, and I think this scenario here on the right hand side is something everyone has seen, right? Everyone's seen these awesome colors of the oil spills and stuff like that, right? Everyone has seen this in your life, right? Everyone's been in a car, and it's something everyone knows. Everyone knows that we pollute. Everyone knows that they have a hand in pollution. So how do we address the complexity of environmental protection? Because whether or not you think about it or not, it really is complex. Um, and we think about the establishment of something like the Environmental Protection Agency as a reaction to how complex protecting the environment is. As you guys probably know, we're a global society. Isolation is not a thing anymore, right? That's just not going to happen, right? And that's certainly true, not just for our cultures, but also for our environment. What happens in the Atlantic Ocean doesn't just affect Florida; it affects Massachusetts, Canada, Brazil, Africa, everywhere around the way. It affects everything. So it really is a global thing. But when we're trying to break this down, you have to figure out, in an idealized world, again, this is my idealized group of things, not like the way it actually is, but who's affected, who's to blame, and what should potentially be done um, to do this, right? And then when we start to scale things up from I spilled oil on a gas station to I dumped 1,000 gallons of oil into the street to BP dumped 3 million barrels of oil into the Gulf, how do we solve large in 2010? You guys probably, well, this is 11 years ago, so you guys were little usually because you guys are in your early 20s, so you were probably little, so you may or may not know about this one, or maybe forget about it. But the Deep Horizon, Water Horizon oil spill is largely considered one of the top 10 or top 5 worst environmental disasters of all time. But you guys probably may or may not know, it was a massive amount of oil, millions of barrels of oil into the Gulf of Mexico, spread over thousands of square miles across the Gulf of Mexico. And this was carried out by British Petroleum, or BP, um, and absolutely awful environmental disaster. I mean, you can just sort of see, you see the thing on fire. I think that illustrates it pretty well with the black smoke. But you just see the boats, right? They're just sitting in like for sustenance, but also for like just the economy and for people's like just average, like I like to go fishing or I like to go on my boat or jet ski, is a really important thing, right? The ocean is a big part of the deep south there. So it's a lot of things that go into it, not just a natural thing, not just the economic thing, but really it's sort of a multifaceted thing, right? It hits all of those ecosystem services overall. So this leads us to the first part of today. where we have something as terrible as this, where at least this is the first part. This is personal ethics. Now you guys know what ethics are. It's your morals, right? Allows you to differentiate what's right or wrong. They vary hugely among people. We use them to make judgments from anything, right? Ethical judgments about personal beliefs, such as do I want to donate money to this X organization, or do I want to throw my garbage on the floor or throw it in the trash, or do I want to recycle or not, right? You guys know what ethics are. Now, we can apply this to an environmental context, and we'll talk more about plastics later this semester. Plastics is everyone's favorite lecture, just to let you guys know. Everyone always loves plastics. But in 2010, the FDA did issue a report that bisphenol A, or BPA, you guys probably heard of BPA-free water bottles, can actually be hazardous, but they didn't outright ban it. They said BPA is bad. It's up to you to decide whether or not you want to use water bottles or things with BPA in it. Now, from this ruling, the FDA, a bunch of companies came out with BPA-free water. You guys probably seen bisphenol A or BPA-free things all the time. It's out there. Just to let you guys know, for those of you that don't know, bisphenol A is just one of many bisphenols they used in plastics. They're called phthalates. BPA has a really cool history. You guys will learn about it. They swapped BPA out for other types of BPs, so bisphenol C and bisphenol F, which are just as bad. So just to let you guys know, if it says BPA free, it probably has another bisphenol in it, unless it tells you it has no phthalates. So this PTH here, just to let you guys know. We'll talk more about that later in the semester, but usually when I bring up bisphenol A, people ask me about it. So I just figured I'd just put it out there. Now, it wasn't banned by the FDA. You could still buy water bottles. In fact, if you buy cheap water bottles, like, so say you went to Walmart and you bought a $3 water bottle, it probably has BPA in it still, and other BPs. But people made an ethical choice, and as you can see here on this label, and companies as well, to stop using BPA as an ethical choice, to stop using it, right? So you can buy all sorts of things of bisphenol A, right? Parents are like, I'm not going to buy water bottles with bisphenol A in it. Or you as a consumer, like, I'm not going to buy this bisphenol A water bottle. I'm going to buy one without bisphenol A. So that's our personal ethics, goes into making those types of environmental decisions. Now, interestingly, when you live in a society, you do have, and we don't really typically think about this, but it really comes back to JFK's sort of classic, not what your country can do for you, but what you can do for your country thing. But that sort of idea, where you do have a moral, whether or not you know it, to sort of be in like the social contract society, there is a moral that we do have that duty and right? So there is this social contract where you have a duty and right to try to protect things as best you can, and as a parent, you have this duty and ethics to protect children, and children have a right to be taken care of. Now, this leads us to what's called deontological ethics. Now, this is an interesting ethical system which is based upon this idea of duties and rights. And actually, for all the terrible things Richard Nixon did, Richard Nixon did use this deontological ethics, or at least his government system did, to establish the EPA, or the Environmental Protection Agency, because it allows the government to assign essentially this intrinsic value to its worth and of itself, which is essentially used to make ethical decisions. Now, the EPA has lots of failings over the years. It also has a lot of successes over the years. But the idea is that it uses the rights and duties of man to essentially, and the ethics of man, to try to make decisions about what's best for people, what's best for individuals, but mostly what's best for large groups of people. Kind of a hard job. As I'm sure you guys probably also know, EPA is probably the most maligned group in the entire government, maybe outside of the CDC right now, because of the whole COVID crap. All the people that hate CDC for whatever reason. But in terms of like the most maligned governmental groups, EPA is definitely at the top, because people like to hate on the EPA quite a bit, but do know the EPA is a really important group. Now, the EPA is our local one. The United Nations does have what's called the Earth Charter, in 2000, which actually outlined some really interesting environmental policies on a global scale. They're obviously non-binding, and they fall into 4 essential categories here. And there's a total of 16 points. You can read through all of them, but they come together. Respect from care for the community of life. So life being an obviously important thing. Ecological integrity, which is a pretty cool one. Social economic justice, as well as democracy, nonviolence, and peace. Now, clearly, this is the one we're thinking about the most, where we're thinking about protecting and restoring Earth, preventing harm to the Earth, adopting patterns of consumption that help protect Earth, and advance the study of Earth. So, the United Nations has ethics built into it from environmental perspective, but remember, the environment is not separate from all these other 4 pillars of the United Nations Charter, or however we think about it. So that's how we think about applying ethics. There's governmental agencies, but there's also personal ethics, right? I'm not going to use BPA water bottles. I'm not going to throw trash on the ground, or the FDA says this is bad, right? Or the not the FDA, the EPA says this is bad. But how do governments do large impact decisions, such as building a dam? Something like building a dam has massive ecological consequences. Think about the Hoover Dam, right? Lake Tahoe exists because of the Hoover Dam, right? But it had massive ecological consequences just building it. So how do we do something as large as, say, the Hoover Dam that provides power to thousands of people, but also requires massive destruction of natural resources or potentially flooding homes and communities to build said dam? So this leads us to the thing that you guys have probably heard, the greater good, right? My goodness, I can't speak today. This word that I'm not going to try to say for a third time, because third time is not the charm for me. Basically, you can be used where the definition of what is right can be determined by which actions would bring the most good or as little harm as possible, right? That's for the greater good, right? It might say, it's like the train track problem, right? Would you divert a train to save 1,000 people if it meant killing 5 people, right? That's the greater good idea. Now, whether something is right or wrong is determined by a balance of the good and bad consequences, i.e., building a dam might uplift 10,000 people out of poverty, but it might also destroy the livelihoods of 1,000 people. Which one is for the greater good? That's probably a bad example because 10 to 1 is not a good investment, but you get the idea. Now, this idea attempts to figure out the total benefits and the harms, and whichever one produces the most benefit is essentially what should be pursued. Now, this leads us, and again, this is not an actualized thing, right? I don't think I need to tell you guys this is the way things should be, and in theory, this is the way things were founded on, but clearly we don't do these things, right? I mean, like, clearly, all the environmental disasters we've had are clearly not in the greater good, right? So just letting you guys, just to preface that again, it's not always a perfect thing, but this is originally how our systems were set up. So we can think about this idea, thinking about these 3 concepts we've discussed. Now, there's sort of 3 boundaries to think about how things affect things. Now, the first one is the anthropocentric worldview that we discussed, where only human needs matter. If it doesn't affect a human negatively, who cares? Let's do it. Right? That's kind of like, building this oil rig doesn't affect any human lives, but it destroys a huge ecosystem. Let's build it anyways. That's anthropocentric worldview. Shit, stop it. Then we get to the biocentric worldview, as we discussed, where all living things matter. So thinking about, okay, I'm not going to build a wind turbine here because it kills birds. Though, fun fact about wind turbines, you can paint them like a zebra, and it actually helps reduce bird deaths in wind turbines by about 80%, which I think is kind of cool. So that's our biocentric worldview. And then we have our ecosystem-centric worldview, where everything is connected, right? And I don't think I need to convince you guys, at least I hope I don't have to convince you anymore, about how important that ecosystem value is to humans. Because, again, if we build an oil rig and it destroys a whole ecosystem, well, it might not directly harm these 2 people or the local community, but down the line, eventually, with that deteriorated ecosystem, it's eventually going to come back to bite these people in the butt. Right? Whether it's storms or whatever, something is eventually going to come back to bite us in the butt. And I think New England is a great example of this, because we used to never get flooding from storms, but then we started building along the coast and changing our coasts, and now we suffer lots of money lost every year from flooding on our coast. So again, eventually it comes to bite you back in the butt. And we sort of want these things, but most people live in this sort of lens, and I hope I can convince you guys not to live in the lens of only human needs matter. But I think one of the other things about this anthropocentric worldview that I just like to make mention of, and it really comes to also inequality, in that, like, if you're thinking about an anthropocentric worldview, you might think of only a few number of people, right? So like building a factory on a river, right? It might not harm like the people who made the factory, but it might harm the people living in the village, right? Or the town or river or the community, right? So I think there's an important point here to be made about anthropocentrism, about how narrow or wide the focus is, right? And I think we can apply that to a lot of things, right? We can think about climate change. It's a great example where if we change to renewable fuels, that would harm, changing to renewable fuels is great. It helps everyone, right? Switching to wind or solar, it's great. It's great for everyone. There's no downsides to those two things. But if we think about it would harm the oil industry, that harms a very narrow subset of the government. I'm sorry, the population, right? In particular, a very small subset of workers and very wealthy individuals. So anthropocentrism has a gradient too, right? It's not just like it harms everyone or harms no one, right? There's a gradient of how many people it can harm. So we talked about biocentrism, ecocentrism, and really a really great sort of take on how to think about the world. Because again, a lot of people can't get past sort of their own, like, this doesn't affect me, therefore I don't care, right? Or like, you see this in politics all the time. Like, I'm against this. Oh, this thing that I'm against now impacts me, thus I'm for it, right? That sort of thing, right? So thinking about yourself is good, but also thinking about others is also a good thing. Now, let's think about money, because money is fun, not just for you guys, it's fun for everyone. You don't have to be a finance major or economics person to think money's fun. Money's fun, allows us to do fun things. Now when we think about the environment, we think about stuff, right? When we think about purchasing, part of that money goes back to the source investors that essentially created that thing you bought, right? So when I buy a burger, right, obviously the people that sold me the burger. So if I go to Wendy's, for instance, I bought a burger from Wendy's, I gave them $5 or whatever. Some of that money goes to lining, paying the workers and all the costs, but eventually it makes it back to the people that invested in it, right? The owners, blah, blah, blah. But eventually I have to pay that backwards, right? So as we'll sort of discuss, you have to pay that backwards, right? That's this economic system where you have to pay to get one burger, takes, 6 pounds of grain, right? 52 gallons of water, 75 square feet of grazing, and 1,000 BTUs of fossil fuel energy. BTU is just British thermal units. It's what the British use and other people use. I didn't have a better figure than this one that didn't have BTUs on it, sorry. But energy, right? So there is a system that goes into place. And while and thinking sort of about how the environment is connected to this, the environment is really these three things, right? As well as the fossil fuel, but there's sort of a chain of events that goes into what we're seeing. And this leads us overall to when there is a commodity, when there's either environmental commodity or something we can use the environment for, it leads to supply and demand. I don't need to tell you guys what that is. People demand stuff. There has to be supply for it, right? So the iPhones are a great example of this, or at least they used to be. Or maybe the PlayStation 5. PlayStation 5 is a great example of this. There's a huge demand for the PlayStation 5 right now. The supply is really low, so thus scalpers are making tons of money by selling all the PlayStation 5s they can get. My friend did that. He made a lot of money. He was a jerk. And so we can sort of think about this where we have dollars per barrel of oil in the year, right? So we can think of massive amounts, lots of money per dollar per value, and then a crash, i.e. the global recession. So the supply the demand was really high, thus the price was really high. Then the financial crash in 2008 drove down the cost per barrel because the demand simply wasn't there. So supply and demand is a thing, but also a thing from a perspective of the environment, right? If the demand for lobster is there, the desire to go get lobster is there, right? If the demand for harvesting, in this case, fossil fuels is there, the environment factors into there as well. So this really really interesting thing put off by Adam Scott. I'm sorry, Adam Scott. Not the golfer. The Scottish economist Adam Smith. You guys probably have read, or maybe you've heard of The Wealth of Nations. Adam Smith is an interesting guy. If you've never read anything by him, I mean, it's old stuff, but it's still actually relatively still applicable to modern day times. I have I'll make mention that I have a degree in history as well as it's like an undergraduate degree in history. So I read a lot of Adam Smith stuff. So that was the time period I was interested in. But he has this idea of the ideal market as an invisible hand. But market will essentially rise to it. If there's a demand for something, it will be there. And so we could think of we could think of petroleum or oil, or we could think of coal. If the demand is there, the technology will come, the business opportunities will come to exploit that resources. Now, this brings us to another interesting friend here, William Jevons. Now, he actually recognized that you can increase efficiency in production and also increases consumption, which he called the Jevons paradox. Now, it's kind of an interesting thing where we have the number of coal, and we have some interesting things. So the steam engine, more steam engines, coal boats, and modern day coal stuff. But you can look at the tons of coal, and you can see how much tons of coal essentially were being harvested, and then it drops down to 10, and then drops down to 9.5, then drops down to 6, then drops down to 4.9, and this is going from 1780s to I was going to say modern times, but 1860s are obviously not modern times. So spanning the beginning of the Industrial Revolution. Now it's interesting. Why is it doing this? Well, we're harvesting less coal, so shouldn't it be less? Overall, there's less stuff out there. Shouldn't it be less expensive or more expensive? But the reality is, as efficiency increases, you need less stuff. Right? I don't think I need to tell you guys that. You kind of have a general idea. So it's kind of an interesting thing, right? You have this sort of interplay between the resource nature has, what's the overall market for it, and it essentially determines how I was going to say ethical, but how what policy or potentially what actions you might take to harvest said resource from nature. So interestingly, I don't know, coal refinery or coal power plant is great, provides energy, blah, blah, blah. But an externality of that would be, well, if I set up a coal-fired power plant, I don't consider the externality of, well, what's the health cost on the people that live near that coal-fired power plant, right? And that's the sort of things we're thinking of, right? And that really ties back to our ecosystem services. If I say, okay, if I'm gonna change the Florida Everglades, how do I rationalize that? If it's $46 billion of stuff coming out of the Florida Everglades, how do I rationalize destroying that $46 billion to erect, say, $5 billion worth of stuff, right? So I think it's kind of an interesting thing. So let's look at some of these things. So we're looking at the Appalachian region, really interesting region of the country, West Virginia, Pennsylvania, Kentucky, Virginia, North Carolina, so on and so forth. Really beautiful mountain ranges. If you guys have never been there, like for instance, like West Virginia is kind of a weird place to go, but a very beautiful place to go. So if you've never been to any of the Appalachian regions, really beautiful place. There's also a trail that goes from north to south. I forget what it's. I think it's just called the Appalachian Trail. It's a really beautiful trail, really long. So obviously, if you're not good at hiking and stuff, don't try to do it. But really beautiful place. Now, we can think about what the Appalachian region is known for, and for those of you guys that know that, the Appalachian region is actually known for coal. It really is. Like, if you think about like during the 2016 presidential campaign, one of the big like pitches that the Donald Trump was making to this area of the world was, "I'm going to bring back coal." Like that was his big thing. And it resonated pretty heavily, especially with the people in West Virginia, because coal was such an integral part of their history. and formerly part of the region. But as we've moved away from coal to cheaper alternatives, coal has essentially gone by the wayside. Not fully, obviously, but in parts of places. So let's look at the environmental impacts of coal. Now, there's clearly an economic value of coal. Now, West Virginia in this area of the world is not doing the best off economically. I mean, obviously, New York and Pennsylvania are doing pretty good, as does Virginia um, and Maryland to some case. But lots of these areas are pretty dang poor, um, even though coal is a big part of their economy. Now, let's look at some of these costs. So we can look at land disturbance. The cost per year range pretty heavily from 54 million upwards of 3 billion. Methane emissions from the mines are pretty expensive, leading pretty high numbers. Fatalities due to coal transport, um, which is lots of money. Public health burden, huge amounts of money. You guys probably know coal miners are famous for black lung, right? They get the more exposure to coal dust you get in the mines, the more it builds up in your lungs, turning your lungs black, starving you of oxygen. So coal mining is not so good, as the same as combusting coal at a power plant, also not good. The pollution, air pollution's even higher, upwards at $187 billion. Huge amounts of money. Huge amounts of money. I gave you the number earlier that 9 million people die worldwide from air pollution. And it's not just the air pollution that kills people, it's also medical bills, right? That's I guess that's an American joke. So cardiac disease, climate damage, and so on and so forth. So huge tolls. You're talking, if you add these numbers up, they're close to $600 billion annually. And at the cost of what? Giving people jobs, stimulating the economy at a fraction of that. You're talking maybe a couple $100 billion. The costs of coal far outweigh the benefits of coal, even to these regions that, again, historically are so heavily depending on the mining of coal. So kind of interesting thing. Now, as we think about applying an ethical sort of framework to policy, brings us full circle back to Tragedy of the Commons that we talked about last class. And there's a great little simulation I might give you guys to do about cows, but this figure does a really good job. That if we have a resource and it's used by a small number of cows, like farmers, well, it's great. There's enough resources to support those cows indefinitely, right? Sustainably. But as we add more and more cows, as we keep using and using and using a resource, again, is designated by more cows, we can see that the cows essentially degrade the area, making it unusable for future generation. Sorry about that. And Tragedy of the Commons can be avoided with good policy. Now we can think about the fishing industry here in Massachusetts is a great, and thinking mostly about the lobster fishery, but also other fisheries where we enact catch quotas on our fishermen, because if a fisherman had his way, he would just catch and catch and catch to rake in the most money in the short period of time without really much thinking about what he's going to do in 10 years, because that's just kind of what people do, right? So it's also sort of an ethical thing, right? People would take. We would do this over and over again, and we have. But putting good policy in place, including things such as the cap and trade exchange, is a great example of this. In 1990, for those guys that never heard, we enacted the cap and trade exchange system that put an overall maximum amount of allowable emissions that can be bought, sold, and traded or banked. So it's kind of a good way to essentially cap what people can or can't do. And that's just a figure of that. So let's look at this in the context of ecosystem services, because I think this is an important way to sort of link the first. Well, we've done a bunch of times, but this is probably the most important linkage between the first part of the class and the second part of the class, where we think about these positive externalities, where a functioning ecosystem, as we know, provides numerous ecosystem services. Now, the markets, as we know, typically tend to underproduce things that have positive externalities, i.e., we don't do things sustainably, thus we damage nature. That's just kind of how we do things, right? It's easier to produce a chemical and dump the byproducts somewhere else than to produce a good chemical and not have the byproducts. So this gives us that we can potentially think about incorporating policy and ethics or thinking about our friends, these ecosystem services. Overall, because again, they are super duper value. Now, these ecosystem services also overlap with our public goods. Now, public good has been described as things that cannot be produced profitably, since non-paying customers also receive benefits from them. That should be in quotes because that's not my words, but whatever. And these include things like roads and public parks, but also natural environments, right? Scenic outdoor environments, things that ecosystems provide, ecosystem services. So I hope I've convinced you that there is an overall ethical way to think about ecosystems. Maybe I didn't do a good enough job. I don't know. We'll find out. We'll find out. We'll find out. But ultimately, the way we think about the environment, the way we use our own personal ethics to think about how to preserve the environment or how not to destroy the environment or how to restore the environment can directly translate into environmental policy. Now, as I said, the SERP was one of the last good things we've done, but we've seen time and time again, we've tried to come up with good environmental policy here and abroad, and it simply fails. With sort of the last good global policy that actually made a difference was actually in the 1980s with our friends at the Montreal Protocol. We'll talk about that later in the semester, but policy is hard because there's, as you guys know, when we talk about politics, there's all sorts of competing interests, both financial from businesses as well as personal interests. And potentially set safety on fuel economy standards for cars, pollution standards on cars. So for instance, like Massachusetts, we have the state inspection stickers that sets limits on how much pollution can come out of your car. If you go to a state like Michigan, Michigan's an interesting state for cars. Those standards don't exist. So they do vary both regionally and within the same country. So it's kind of a interesting thing. But ultimately, when we think about how we shape policy, in theory, governmental policies that are authoritative, decisions, laws, regulations, court rulings that guide the behavior of people. So we identify problems to address, crafting a policy, all that stuff about approving policy, Congress, state and local governments, things like that, eventually implementing policy, and eventually sort of the part that we don't like to do or don't do well is evaluating policy overall. Is it actually working? Is, implementing fuel efficiency standards actually lowering deaths due to air pollution, things like that. And so I hope this sort of really shows you. I really like this figure because it really highlights the way you have to sort of think about environment in policy, because it starts with problems, which is a scientist thing, then policy, which is a lawmaker thing. So political sciences, as is evaluating the policy, but that's also a science thing. And then improving policy, which again is a government thing, but people get elected to the government because people vote them in. So that's your voice in there. And then the policy is implemented by people and by the government. And so it's really this nice crosstalk between the political science, the political narrative, as well as scientists. And now this part, as we know, doesn't work so well. This part also really is poorly done as well. But this part really doesn't work too well, unfortunately. I don't need to tell you guys that. So this leads us to environmental policy in the United States. So we'll talk about two issues that we typically focus on. So pollution regulation and natural resource management. Now, natural resource policies actually have been existed for quite a bit till the late 19th century, when industrialization actually prompted us to invest in resource conservation. And the essentially the interest in preserving public land actually dates back to our friend Teddy Roosevelt, who actually dedicated the first national park at Yellowstone in Montana and Wyoming to the natural forest protection. So it is older than the EPA, but our policy does have some root in some people. Now, we also have numerous land use agencies to respond to environmental policies that need to be done: the National Park Services, the U.S. Forest Service, the Bureau of Land Management, and the U.S. Fish and Wildlife Service. We also have pollution agencies such as the EPA. They're the big ones, but they also helped enact the Clean Air and Water Act, one of the most successful things we've done, actually. Clean Air and Water Act was pretty dang good. Increased life expectancy in the United States by about 5 years, just pretty impressive. So some pretty good things. Now, at the state and local level, the federal government does set minimum environmental standards, but we can look at California. California's leads the way in environmental policy. I'm sure you guys probably saw to the ire of the previous administration, how much they disliked California's enhanced fuel standards. So you can have enhanced levels of standards at the local level, which is good. Texas is an interesting state because Texas is a big fan of deregulation, but they do have a number of pretty important state agencies, such as the Texas Commission on Environmental Quality, their public utility commissions, as well as the Texas Park and Wildlife Department to oversee all the national regulations. They don't implement very much of their own, but they do have some pretty good local things to enforce them, which I think is a pretty good thing. Now, this leads us to global policy, which is, for lack of a better word, awful. We could see a really good instance of global policy with the Montreal Protocol back in the 1980s, but also the Paris Climate Accord from a few years ago. Global policies, generally speaking, are more suggestive. They're typically not binding. But as I mentioned, environmental policies cross borders, they cross nations. So it does require us to do something about it. So things such as acid rain, that are a result of combustion of coal in the United States affect Canada. So global policies are a thing. Now we can also think about what we do with our waste. For instance, we can see here there's a number of what we call IGOs, intergovernmental organization that do provide venues for different things. And the United Nations is the single largest one with 193 members. But generally, the things the United Nations do is not non-binding, unless it gets like a super majority. Then in case it becomes binding to the people that signed on. So we can see a number of sort of important things, including our really important sorts of ones, including this Montreal Protocol in 1987, some other important things such as the International Trade in Endangered Species one, CITES, it's a really important one, Paris Climate Agreement in 2016. So global policy does work when there's enough need for it. It's going to be interesting to see how global policy changes going forward. We have climate change; it's kind of right in our face right now, but it's also the future demon as well. So it'll be interesting to see how climate change is factored into future global things. Not so much the forefront right now, but eventually down the line it will be inescapable. The people that do the most polluting are the wealthy and large corporations, right? If we think about something like greenhouse gases, 70% of all greenhouse gases come from 100 companies. Not you, not the people in Africa burning wood for their fires. It's large corporations. So the biggest thing you could do in terms of economics and policy and all that stuff to do is actually is reigning in policy, voting and things of that nature. So, and there are other things that I'll list here that you can read at your leisure. But again, the biggest thing is changing governmental policies. You know, the individual doesn't, when you have global issues, doesn't make such a huge thing. So, and that is going to be it for today. Let me stop sharing.